So I guess it's time to start. So welcome everybody. My name is Francesca Moglia and I'm working as a laser expert for EPIC. And today I'm really pleased to be here with you to present these new products. So 5 of them in this new EPIC new product release of 1st of March. And so let's just go running. So as you see here, this is just the 5 companies that I mentioned. So we have TeraXion, Photonics, Luxinar, SILIOS Technology, and Menhir Photonics with us today. But before we go into the deep topic of this meeting, let me talk a bit, just 2 words about EPIC. So I like to say always that EPIC is the best way to describe it is to show this slide because it's you, so the members. 5 of them, they see probably our 5 people today in the room presenting their product will see their own logo there, very small. But this is together to other more than 750 companies in this slide, presenting really all the photonics community and that we build and the photonics ecosystem that EPIC is representing. Now, just a couple of words about what EPIC is doing. So here you see these fantastic 13 people. I include myself, I'm fantastic as well, of course, but the other 12 even more. So this is just to tell you, on the left side, you see basically a summary, very compressed of what EPIC is doing for the members and for the, in general, photonics ecosystem. So what we do is providing a support, so support from different aspects. So one is the technology aspect. So you, as a member, you can get basically from the technology team, so more or less half of the team in this picture is dedicated to technology. And what we can do for you is really a tailored support in terms of finding some supplier for you, maybe going towards access new markets. So this is something that is really, we do one-to-one with every one of you. And then there is also this service of market reports. We buy commercial ones, but also since we have Tracy on board, one of our colleagues, she's really taking care that also special market reports are made on special topics that we think are really hot topics and important for the members, and they are really prepared just for EPIC members. So this is really a super added value, in my opinion, and also from all the team is really important added value. Then there is more the marketing and events support. So we have a fantastic part of our team that is also dedicated in organizing marketing that is also service supported and made on tailored, let's say, for you through our social media, but also the website and anything that is can be like this. Also event here is supporting really your products in also from the marketing side. And then we have also the part of the events that can be talking about technology, but also about more technology and networking. So we put really people together when it's possible in person, but also online. We have a history of both. So I guess we can support you in any condition that you are basically in everyday life, let's say. Then also thanks to some EPIC members, we provide the mentorship program. So let's say the most experienced C-level people in EPIC really offer more than 100 people are willing to help others that are maybe beginning, they are startups or they have some specific business issue that they do like to discuss with someone that has a lot of experience. This is a service we provide as well. Then we know HR, finding good people that can deal with photonics, can get into your technology and really provide support. Also from the marketing side, of course, we cover really all the possible positions that our members have open are on jobsinphotonics.com. And so also applicants can find basically a collection of them all together in one page. And this gives, of course, a big value. And then last but not least, if you need some support also from the investment side, EPIC is there for that as well. But now let's not talk about too much about EPIC. Let's talk about these 5 fantastic people we have here today, talking about their fantastic products. So here is a bit the menu for today. So we will start with Ben, coming from Luxinar, who will tell us a bit about this, one of their new, let's say, kind of sources for as ultra-short pulse laser. We will hear from him already, but his matter really of controlling power and also pulses in burst mode to really access the best application that you want to really address in your as a system integrator or also as end user. Then we have the expert of laser systems components, TeraXion. So Pascal is here today to present us a bit their new Med2 series. So is a special laser reflectors for high power application, especially 2 microns. So for medical fiber lasers, this is one application. And then we will hear from him also what are a bit the expectation towards the future products that TeraXion is thinking about. Then it's time for another laser manufacturer of Florian from Menhir Photonics. He will be more on the side of the ultra low noise. So the lasers from Menhir Photonics are famous to be ultra short pulses and for synchronization and for different applications. So I don't spoil already the surprise. Florian will explain a bit more what is that the Menhir 5050 is about to do and can do also for you. Then we move a bit towards the spectroscopy and imaging part, and will be time for Slava, from our president of Earth Photonics. We'll present this probe, so really a new fiber that you can really use for different applications in spectroscopy. And we know broad range, but he will give us a lot of examples about how to use this new probe that is unique also for this multiple application you can use it with. And then last but not least, it will be time from Thierry from SILIOS Technologies. There, he will present today Toucan as really one of the snapshot multispectral cameras with the broadest spectral range. So he will show us that really they can address visible to near infrared in a unique way, in a unique broad range. So now, please, this is the introduction. Now I have to give the floor to the first speaker, because it's the best when Ben directly can share their screen and give the floor also to Luxinar. So Ben, thank you for being here. The floor is yours.
Okay. So thank you very much for the introduction. So I'm Ben Fulford, and I will be talking about the LXR femtosecond laser sources and power with control from Luxinar. So I'll start off giving a quick overview about who we are, and then moving on to the LXR series with an introduction to the series. We'll have a look at the power stability and beam quality. I'll have a look at the pulse on demand feature and the fast burst mode feature, and then finish off with a summary at the end. Okay, so Luxinar, who are we? Well, we are a laser manufacturer that's been around for well over 20 years now. So we're based in East Yorkshire in the UK, and we primarily make CO2 laser sources, but we are branching out into the femtosecond laser sources. So we have 6 sales and service centres worldwide, and the company is approximately about 180 employees now, I believe. Okay, so an introduction to the LXR series of femtosecond lasers. So the lasers use patented technology, so this allows us to give high output power with control. The lasers have a large dynamic range of pulse repetition frequencies and energies. Beam quality is very high, with M-squareds better than 1.3. We have a pulse on demand feature for high quality processing, a fast burst mode for increased efficiency with some of the processes. We also provide a PC app with each system, giving local or remote diagnostics of the system. There's a handheld touchscreen interface available. And for the infrared systems, we have 50 watts and 120 watts rated power systems available. And also the second and third harmonic variants available at 515 and 343 nanometers. So the table on the right hand side just gives a very basic overview of the LXR 120 1030. So 120 watts average power, pulse duration 900 femtoseconds. So individual pulse energies up to 120 microjoules, with a maximum fast burst energy of up to 600 microjoules. So the laser can actually be controlled from single shots all the way up to 40 megahertz. Excellent power stability and beam quality. Output is linearly polarized, with beam diameters around about 3 millimeters. So looking at the power capability of the system on the left-hand graph, you can see that this has been taken over a period of approximately 10 hours. Stability is excellent, standard deviation about 0.26% of the average power. The image on the top right, that is a typical focus of the beam, and the sort of caustic plot below it. So you can see from this that the power stability and beam quality of the systems is excellent. So the pulse on demand feature, so this is something that allows the laser to be controlled by an external source. So the external source can essentially tell the laser when to fire. So this is a useful feature if, for instance, using scanners where the mirrors are accelerating and decelerating. So you can see from the images below, without using this feature, you get a bit of a sort of a mess around the corner, whereas this feature, when it's enabled, you get a much cleaner process. So during this process, if the scanner is asking for a different frequency, for example, the pulse energy can be maintained whether 10 kilohertz is required or 10 megahertz. There's also a sync output, which enables the scanner to synchronize exactly with the laser output also. For the pulse on demand feature, we can actually operate this in a burst mode as well as gated. So the individual pulse energies can be set for each pulse within the burst. So the example here is a intraburst frequency of 10 megahertz, 50 pulses within each of those bursts, a burst frequency running at 100 kilohertz, and the whole thing being gated at a frequency of 10 kilohertz. So very flexible in terms of the control. So this example just shows how we've asked each individual pulse within the burst to have a specific energy. And this example here also shows a similar thing where we've actually requested each individual pulse with a specific energy, and you can also see it's actually operating at 9.96 megahertz, so very high frequency to be able to control that. So the fast burst mode for this is a key function for applications such as glass separation and drilling. So this can actually increase the efficiency of material removal whilst maintaining the high quality machining afforded by the femtosecond lasers. So this works off the base frequency of the oscillator. So this time the period between pulses is very short, around 25 nanoseconds. So we can now have the high energy pulses of 120 microjoules, but in bursts. So for instance, this burst here shows about 600 microjoules in total. So to summarize, the systems have a large dynamic range of pulse repetition frequencies and energies with excellent power stability and beam quality. Pulse on demand and fast burst mode are also available with a PC app with local or remote diagnostics. So we have infrared systems available at 50 watts and 120 watts rated power with the green and UV variants also available. So thank you very much for listening.
Thanks a lot, Ben. Thanks a lot for the introduction to your new product. So now we can come back to the room. Maybe you can stop sharing, Ben?
Yep, sure.
Yeah. And let me see. So, of course, every question is welcome for all of you from the YouTube also observer now that are watching at least those who are watching the streaming, of course. Otherwise, you will have to reach out to me if you have some questions, and we will give it further to our speakers. But now let's maybe talk a bit, Ben, about the other two wavelengths that you're offering, right? So all the data that you show were benchmarked on the 1 micron, right? Can you maybe give us a comment about how the stability is for the others? What are for example, also just the power and energy that I suppose is a bit lower, it's normal, but just to give us a kind of a bit of other data about it.
Yeah. So the green systems, we have an 80 watt version in green, and I think 35 watt version also. The UV versions, still working on those, but they probably be 40 watts and I believe 15 watts variants. In terms of beam quality, the actually remains excellent. Pulse duration probably drops slightly, so nearer towards the 800 femtoseconds. But those systems are also very, very stable as well.
Okay, very good. So now from your application that you reported, you were saying, okay, using scanner would help, and also a bit the glass processing systems. Do you have something else in mind, maybe for some specific wavelength? Because with 3 different wavelengths, of course, you don't do the same with all 3. Otherwise, you wouldn't offer it, right? Do you have some other maybe wish application, or where do you think that is the best way to go for you? Just an example. We don't want to tell you too many of your secrets.
Yeah, it's hard. It's a very difficult question because there's so many applications out there, and each application, depending on the material, favors a different wavelength. So it's difficult to answer. I suppose, for instance, glass separation, that does favor the infrared, for example.
Okay, but then it's more towards display application, or do you have something that goes in that direction, or more on smaller, like more microfluidics, this kind of glass? What is that you are thinking about?
It's more about sort of glass separations, such as cutting mobile phone screens.
Yeah, so like large and fast, right? Because we talked at the beginning about this and being high throughput. This is one of your plans. So of course you want to be fast on, or maybe on a flat surface. That is the idea behind it.
Exactly. The high average power is high throughput.
Very good, very good. Then one thing, just a bit more technical, the switching between the different modes, so also in burst mode, is all we saw in your slides that you had mostly this kind of software that is all. So is it all? I would say I expect is just for the end user, very easy, right? To change quick and.
Yeah, absolutely. So the system is shipped with a PC application, and all this can be controlled via a PC, laptop, or even a handheld touchscreen device. Similarly, on the rear of the laser, there's also some D-subs where the user can actually connect their own signals to if they wish. So it's very flexible in terms of its control.
Very good, very good. So if anyone here, so Ben is still here. So if you get some questions also from outside, please feel free to just maybe Tracy. Tracy, do you want to? Yeah, that's very related to the last question. So Tracy, please.
It is. So I was watching, I'm sorry, I came in a little bit late, but I saw your image from looking at a right angle turn, and that was quite impressive. So I was interested in more of how easy is this for a user to program, and also is it something that can be done on the fly, or do you set up the program and then it takes longer to program it for the next thing? How quickly can you switch between different modes?
So in terms of switching between different modes, it's as fast as you can click a button in the software. However, in terms of actually programming the cuts, what you want to do, it's very dependent upon the actual, I guess, the scanning software that you're using, the sort of partner equipment, if you like. Okay. So our laser is able to take these signals and do what the equipment is asking it to do.
This is great. That was really impressive, showing that right angle turn. That was great. So thank you.
Thanks a lot. Yeah, that is also one of the strengths, right? So any trigger signal can speak basically from your integrator or end user, speak with the laser, and then that is also pretty quick then switch of anything that is needed for the application. Yeah, thanks a lot, Ben. Thanks a lot for this. And if any question comes further on, please join us, stay with us now for the discussion of the other speakers. And now we can maybe move to someone that has something to put in different lasers, not only the big one, but you need also the components. So it's time now for TeraXion and for Pascal. So Pascal, please, you can take the floor.
All right, thank you.
Thank you.
Sharing my screen. See it?
Yes, the floor is yours.
All right. So thanks for the introduction. Hello, everyone. Today, I'm pleased to introduce a new product that TeraXion is launching for medical fiber lasers. TeraXion is an indie semiconductor company. We were founded in year 2000. We are designing and manufacturing innovative photonic components with more than 170 employees. And the TeraXion office is located in Quebec City in Eastern Canada. Our products are based on 3 supporting technologies: FBGs, since the very beginning of TeraXion, integrated photonics, and low-noise semiconductor lasers. We are selling components for laser systems, including high-power lasers and ultra-fast lasers, for optical sensing, and for communication. Today, the focus is on a new product in the high-power family here. Our new product targets thulium fiber lasers, a newcomer to urology. Currently, the holmium YAG laser is the gold standard for laser treatments for kidney stones, prostate disorders, and other conditions. Thulium fiber lasers offer several advantages over holmium YAG lasers. First of all, the wavelength, because water absorption is much stronger at the thulium fiber laser center wavelength compared to the holmium YAG laser. Also, a larger range of pulse energies, higher rep rate, smaller fiber size, and all of this contributes to higher ablation rates, finer dust size, less retrorepulsion, and overall more predictable treatment endpoints and shorter procedures. And with a bonus, a huge improvement in the size, weight, and power of the laser. Here's shown a typical design and key components of a thulium fiber laser. FBG reflectors are needed to define a cavity, and the critical requirements for these reflectors are a very high reliability, a signal peak power handling of at least 600 watts, a peak power handling of at least 1300 watts for the pump. All of these power handling in the millisecond range. It's a pulse laser. A center wavelength of 1940 nanometer. And these FBGs must be provided in typically in 25400 double clad fiber. Now, fiber lasers are widely used in industrial applications at wavelength around 1 micron, and FBG technology is quite mature. But specific challenges exist at 2 micron for FBGs, and the main challenge is really to limit the heating of the FBGs at 2 micron. Conventional processes that are employed at 1 micron are not suitable for 2 micron. If you use them, then you'll almost certainly end up with fiber fuse type of damage because of FBG heating. Our solution for this application is the Med2 series HPR. HPR stands for high power reflector. The graph on the left shows a comparison of the relative temperature increase of conventional versus Med2 FBGs. We have been able to demonstrate a tenfold improvement in the heating of the component. You can also get a sense of FBG heating looking at the center wavelength drift of the laser as a function of the laser output power, as shown on the graph at the right. You can see that the center wavelength drift is 3 times less with the Med2 series compared to conventional FBGs. So thanks to these results, we can now offer a signal average and peak power handling of 100 watts and 1000 watts respectively, and a pump average and peak power handling of 200 watts and 1500 watts respectively.
Wow.
And so, in summary, the benefits of TeraXion's Med2 series HPR are a very low heating, which translates into long-term reliable operation, a low insertion loss, which promotes lower cavity losses and lasers that are less prone to self-pulsing, consistent performances, allowing for consistent laser output characteristics, flexibility, which means that we can tailor the reflectivity, bandwidth, type of fiber, etc., to help you reach optimum performances with your specific laser design. And also partnership will work together to quickly iterate and converge to a winning solution so that you can enter the market as soon as possible with your product. So we invite you to contact us today if you'd like to discuss your specific thulium medical fiber laser needs. Thank you for your attention.
Thank you very much, Pascal. Thanks a lot. Can you maybe stop sharing the screen so we go back to the room?
Yeah, sure.
Where the discussion is always better.
Just a moment. Sorry.
Very good, perfect. Thanks a lot. So Pascal, now a couple of questions about your product. So is it correct that this is now tailored exactly, you brought already, is not only to micron, of course you are not directly connected to the application, but of course to the wavelength. So that is clear that the thulium laser to 2 micron is a bit also the success that is of this product, because basically that is the wavelength you can serve and also the high power level at the same time. So that is the success part. But is it correct that is it mostly for CW and quasi-CW operation? Is it correct?
Yes, that's correct.
So what is it, for example, now, of course, we at EPIC, we always want to look at the future, right? So we look at it, this is a fantastic product already. We believe there is a lot of also people in the room that can be interested in this. But what is it that you see that could be a further step? So I have 2 questions mostly. The wavelength and the, let's say, operation mode. So where do you see more possibility to change? So I'm thinking about the mid-IR, because here we have especially one person representing the mid-IR community, and in general, EPIC is really strong with this. And so a couple of words about the mid-IR range and a couple of words about the pulse operation. What do you think is the two, a bit of comments about the strategy there, and what is it more important maybe than it is needed?
Yeah, so right now we have a very important product development project to introduce this medical product at 940 nanometer. But in parallel, we have a technology project at TeraXion, and basically we're looking at we're doing spectroscopy in the thulium band, and we are exploring the limits of what we can do at other wavelength than this one. And there are other applications in the industrial market and defense as well. So we are definitely that's the very first step of a push I would like to pursue in the infrared at TeraXion. So we're really focus on this product right now, but we have activities to enlarge our field of view, I would say.
That sounds great, because that is exactly what you want to hear, right?
Yeah.
Already the new plans and the direction. So that means that basically you see more the wavelength is the challenge more than the pulse operation. So the operation mode is something that is now, you're fine with CW and quasi-CW. Is it correct?
And as long as we are talking about pulse duration in the millisecond range and basically gain switch laser at 1940, that's where we have invested the most effort. And if we are looking at Q switch or things like that, we need to work more on finding the limits at specific wavelengths. And yeah, so there's still some exploration needed to push the limits for the application.
Yeah, and also, you know, I know what you need. Someone to talk to that tells you we need it, right?
Exactly.
That is what helps the most. We know that.
Yeah, exactly. Exactly.
So maybe let's see what has Andrea in mind. Andrea for Convergent Photonics, please, you can ask your question. Thank you.
Hi, Pascal. Do you have any possible components that maybe can be used in a holmium region of spectrum, so around 2 micron and 10, 2 micron and 8 nanometer? Have you ever developed any specific component for this kind of lasers?
Good question, Andrea. We have been producing gratings in silica fiber that shows a steep increase in that region of the material absorption. So we can produce gratings still in silica, and I think we'll explore other material as well in the future. But yes, to answer your question, I think we produced gratings up to 2100 nanometer, actually.
Sounds like we are getting there, or you got already there. So maybe you can talk in private on what maybe you can do for Andrea, correct?
Sure, will do.
Great, that's exactly the questions I want to hear and the comments I want to hear. And now maybe Pascal is happy and we can go on.
All right.
Thanks a lot, Pascal, for your contribution. Stay with us. We have still people to discuss, other topics to discuss. For example, we want to see what Florian from Menhir Photonics brought us today. Florian, do you hear us saying that?
Yes,
we see
I
you
do.
And we hear you. So now the floor goes to Menhir Photonics.
Hi, everybody. So thank you for EPIC. Thank you, Francesca. So I'm Florian, CEO of Menhir Photonics, and I want to present you the newest version of our Menhir 1550 today. So to complement what Ben have presented us before, Menhir Photonics is a Swiss-based company created in 2018, already more than 10 people working, and we are delivering lasers worldwide to all our customers. So as I said, compared to what Ben has presented, which are more focused on machining or medical applications, Menhir Photonics is really focusing on the application of femtosecond laser, which are more related to research, telecom, and space-related applications. So for us, the goal is to bring this type of product to a high level of maturity, reliability, to make it easy to use for the people that are not used to femtosecond laser, to really close the gap between this photonic industry and this electronic industry, bringing this new range of product to an industry which is not used to that. Okay, so on that respect, I just want to make a quick highlight on what we do compared to other laser company. Our laser need to be seen more like a laser clock, to be simple, ultra precise metronome. You can imagine pulse trains coming, 1 gigahertz, for example, every 1 nanoseconds, and you can use that pulse train to transmit time, frequency, really precisely, or to use the whole frequency principle to kind of calibrate in the optical domain the spectrometer in space or on the ground. So on that, our application are really targeted to a different range. Typically, it will be microwave generations, meaning how to generate RF signals based on this laser clock in a deported way or on-site, to also clock many electronic components using a laser, or finally use this frequency comb-based application in order to calibrate spectrometers in a really precise way for metrology institute or for satellite in order to make spectroscopy in space. So from this respect, we have been started 4 years ago with a laser that you can see on the back, and we have been really focusing on a specific type of product, which means that we are working on laser at 1550 nanometers in the telecom wavelength, where you have a lot of lasers that are operating at lower rep rate, 10 to 100 megahertz, based mostly on fibers, which are focusing on different type of applications. Other solutions operate at high rep rate with lower maturity at the moment, and we really focus in the middle range, how you can make reliable and turnkey system from 200 megahertz to a couple of gigahertz fundamental rep rate and higher rep rate in the futures that can be used in all the applications that I mentioned before. And so based on the experience we had and all the customer feedback over the last years, we have now released our newest version and improved version of our Menhir 1550, which is this product I want to show you here. So in a simple and really well-designed box, we have a laser which is fully hermetically sealed, all in one system. You have all the optics, electronics, power supply needed, and it's really a fully turnkey system that can be used from people that are not used to operate such a femtosecond laser. In terms of specification, which are specific to our market, we have, as I said, focusing on high rep rate up to 2.5 gigahertz, fundamental rep rate, clean soliton pulses, telecom wavelength, and also the lowest phase noise laser on the market, which is one of the key aspects in some of our market. To just give you maybe a quick overview of the laser parameters that we can offer, as I was saying, we are operating in the telecom wavelengths around 1550 nanometers with a clean sec-square spectrum. We have also clean femtosecond pulses in the type domain, and the advantage of this laser, you can directly convert it in the RF domain and use it as a photonic quartz in a sense. And so from that, we didn't only bring the laser technology to some lab, we really work on making it easy to integrate with this new product to be usable by many of our customers and to make it integratable quite easily for timing distribution system and other application. And that's what we have developed with this new product, a laser which is only using industrial connectors, only need 5 volt to amps, and have also a whole digital connection interface in order to be able to make long-term monitoring, predictive maintenance, and in order to push this laser performance up to 10 years and more. And so really, in this all-in-one system, can be now available to use for integrators in a field that were not used to deal with femtosecond laser. Yeah. So that was a quick introduction of our newest Menhir 1550, and I hope that give you some interest to contact me more and know more about what we can do with this new product. Thank you.
Thanks a lot, Florian, and for this introduction to your new product. And maybe can you give us a bit of a couple of words of what were your last really developments from your previous product to this one, so that people understand a bit to where you are going, and also to where you your customer can profit from
So if you see the difference between what you can see on my back and what you see here on the screen,
Yeah,
the form
example.
factor have changed. So of course, at least this development were mostly driven by kind of increasing the producibility and the industrial quality of our laser. We are of course always pushing for new additional feature, better performance, but what's quite key for us is not only to make a good laser for laboratory usage, but to make a really good product that can be easily producible, long lifetime and more lean productions in order to increase productivity, reduce the price, and also integrate market that need higher volume.
This is very important to know because that's where you want to go also.
Exactly. At least it's for us, it's always finding the trade-off between the need from the market, which require customization and a specific demand, and being able to bring more and more maturity and reliability to this customer, which are typically operating laser 24/7 for many years to distribute timing signal.
Okay, now maybe we stop the sharing so we are back all in the room. So maybe I have also one more question that I was thinking before. So basically you were mentioning for your you showed basically 3 main applications where you mostly are, actually you talk about integrators, but is it really the case? When is it in your let's say if you talk about stakeholders, your final customer could be both an integrator, but also directly an end user, right? Because you are trying to use a turnkey, provide a turnkey also system. Where do you see that how you can basically adapt to your potential customer, and how is it the part where is more turnkey and nobody needs to touch it? So where is where do you see the important and the flexibility of your product there?
So no, it's a good question. At least I think femtos like laser by itself will always be only a component. It's just an expensive component, but by itself it doesn't do anything. It needs to be integrated into a macro machining system, into a Microsoft system, into a timing system. So for us, a femtosecond laser will always stay a component. Just by pushing it to a more turnkey levels, higher reliability, it allows us to integrate markets that were not available before due to the kind of non-easiness of integrations and the need of having someone always taking care of the laser. So now by bringing this turnkey laser, we bring kind of this femtolaser component to a new range of integrators in our view. And of course, integrator can be large industrial integrators, but can be also OEM scientific integrators like particle accelerators, satellite producers, and others.
Very good. Then I guess we have a question from Tracy from application side, maybe. Tracy, please.
Yes, so Florian, I'm sorry, this is a little bit esoteric perhaps, but I was really interested when you mentioned the laser clock and within the confines of satellite communication. And so are you using, so one of the issues that we have now is what is the accurate source of the clock, and how do you maintain that source of clock should that initial clock leave? So are you using, say, a cesium or a strontium clock initially to set up the clocking time? And how are you handling the synchronization? I don't know if you can.
Yeah, so I can reply. So when I was mentioning laser clock, I was simplifying a lot the concept. Of course, a clock, there is the precision and there is the accuracy. And in our case, we are not on the long-term accuracy and precision of our signal. So meaning that we are not, like you mentioned, cesium and over atomic clock. When I mentioned the laser clock is meaning saying that, well, a clock is a tick-tack with a given rhythm. And of course, it can be defined from its accuracy point of view or precision point of view. And each of these 2 parameters will define also from the swap of a system in which field of application it can be done. For us, we are more on the transmission of this signal.
Okay, this is very interesting.
So we are referencing our laser onto Maser RF reference or atomic clock, and our laser are being used to transfer this really precise signal. And because they are intrinsically low noise, it's easier to reference it and use them for this application.
Are you using GNSS as the initial base?
Yes, at least we use
synchronization.
That's really depend on our customer. Each of our customers are using different type of reference depending on their budget. needs, I would say.
Wonderful. I have more questions for you, but I'll save them for later. This was very interesting. So
my pleasure.
Thanks a lot. Thanks a lot. So now that we are here in the room with all these ultra short pulse laser experts, maybe we can have a chit chat also with someone of you in the room. And one of these could be, for example, Mathieu from Femtoeasy. Thank you for joining us today. Can you maybe tell us a bit what is that interested you in this meeting? What, of course, you are doing so that everybody gets to know each other in the room.
Hello, everyone. So yes, I'm here with Femtoeasy. So we are a manufacturer of ultra short pulse laser diagnostics. So autocoagulars or frog systems, and we specialize in innovative systems with ease of use, compactness, robustness. So yeah, I was interested, of course, in the talks from Florian, who I've known for some time already, and also from Luxinar, because they are also involved in the femtosecond market. So I would be happy to discuss further with those people or other in the room. But yes, we are specialized in that temporal characterization of femtosecond lasers, basically. So thanks for giving me the opportunity to introduce ourselves.
Yeah, you're very welcome. So you know already the new people, the old people, who knows, maybe with the new products, they need the new challenges. So that's also always the possibility. So now we are kind of abandoning the laser field, let's say, for today. So if you still feel free, of course, to think about some questions, you can still ask them later, no problem. But now it's just a bit to introduce you towards more the spectroscopy and imaging part of this meeting. So it's time to give the floor to Slava, our friend from Art Photonics. I'm really pleased to have you here today. So please, Slava, the floor is yours.
Thank you. Thank you. I would like to say that we shall leave the area of lasers because our business was started from delivery with fiber optics of any laser light from UV, from XML lasers up to CO2 lasers. So that's why, in general, I will probably share my screen and show what I prepared for today. But just for all the other speakers, thanks a lot. I can say that even for the femto lasers, there are very new solutions, which I will not present today because, as I said, it was another topic prepared. But so-called negative curvature fibers, you know, which can really deliver even very short pulses without dispersion, is probably something we can discuss later on. Because there, you know, with all my respect to the laser, because my guru was Nobel Prize winner for laser invention, Professor Prokhorov, you know, I could say a laser is still a type of lamp, you know, and question, you know, how to deliver light from the lamp to the target. This is our, let's say, duty, because we must simply, I don't know if you see my screen now.
Yes, we do.
Okay.
In case nobody knew, Slava is really full, Art Photonics is really full of resources. So of course, there is always an opportunity to talk also about serving the laser field. But yeah, please, Slava, go on.
Yeah, fiber optic manufacturer. We are, let's say, less than 30 guys in Berlin, in biggest technology park of Germany, in Adlershof. And we really provide a very broad area of fiber optic bridges, I should say, for laser power delivery, spectroscopy, imaging, and so on. But today, just to use my, let's say, time slot and not to delay it, I would like to go in, how to say, telegraph style through a couple of products which we consider like really new to promote on the market. And idea that maybe a lot of you or almost all of you knew that spectroscopy is possible not only when you bring a sample into spectrometer, but when you connect spectrometer with a fiber optic, you can go in pipe, in your cup of coffee to measure sugar content, or in chemical reactor, and so on. The innovation in this field, we would like to present that we can combine in one probe, in one fiber spectroscopy probe, two methods of spectroscopy. today it will be mostly only two of them. So near Raman and fluorescence together with mid-infrared fiber solution. So when we started to develop them, we simply decided to, how to say, to use a concept of equal rights for every method to be used. So liberté, égalité, fraternité. So in this case, égalité, because a customer should be free, liberté to select method, you know, and method has the right to be used. So question how to combine a couple of methods in one and what for, it's according to the French word fraternité. So that's why in this case, you see, we have any kind of fiber optics from UV, from let's say 250 nanometers up to, let's say, 16, 18 microns, you know, which we can use for the coupling of Raman spectrometers, FTIR, fluorescence, near-infrared, and all of them can go in reactor. And then you can select which method will give you better, let's say, and more precise, more accurate process control. When the process is changed in time, you see how product is formed, in this case, under 220 degrees C. So plus a general, not only competition between methods to select one, because if there are not still very good parameters from one method, then idea is really how to combine it. We manufacture hundreds of different versions for fiber optic probes, where you can combine, for example, in one probe, laser power delivery for fluorescence and collect fluorescence signal with these fibers. But you can also use it, okay, it's not clear after Sapphire window, for Raman spectroscopy. But you can also use it for near-infrared diffuse reflection. So that's why even same fiber optic probe with many fibers can be used for several methods, which can be used later on for data fusion. So that's why here, one simple example, but let's say a lot of work behind, that we measure not only transmission in UV with this fiber optic probe, we also measure fluorescence in perpendicular direction, and we also measure scattering. So simultaneously, we measure transmission, scattering, and fluorescence. So three methods united in one fiber optic probe, combi probe. And then customer can, in this case, it was company Sartorius, doing biofermenters, you know, so how to select optimal parameters when the process must be ended up for highest yield, quality, and so on. Okay, I already, you saw from my first slide that we united in one shaft, Raman probe at one window, and another one is for diffuse reflection. It's absolutely complementary data, because Raman will give you information about symmetric vibrations of molecules. You can see specific absorption bands, while near-infrared will give you first harmonic of absorption bands, which is asymmetric vibrations of molecules. So when you have information about symmetric and asymmetric vibrations, then you can really make a more accurate conclusion about composition. So that's why this probe has not two ends, input and output, but four legs, because it really connected to two spectrometers. I already mentioned that we are, let's say, fiber optic company. We have maybe the best portfolio of infrared fiber solutions. So chalcogenide for the range up to 6 microns. My baby, you know, this polycrystalline fibers, this yellow stuff, which covers the range up to 17 microns. And last year, we also started to produce our own hollow waveguides. So, but from this kind of, let's say, HOSES, we are able to use not only one method and not only one type of spectroscopy method, but several. This kind of, let's say, concept came from our wish to help surgeons, in oncology, how to distinguish tumor margin. because they are doing today up to 50 or sometimes more than 50% mistakes. They never know exactly where is the border. That's why either tumor is not completely removed, or let's say it's too invasive. One method helps us, this is, for example, fluorescence and infrared absorption. One method gives you a chance, to distinguish, but with some overlaps, with mistakes. Another method can be a bit better, but still mistakes. As soon as you fuse the data, you see no overlap here. So that's why fusion of spectral data from two methods provides you a chance to make much more accurate, let's say, differentiation between cancer and non-cancer. Again, just to mention that it's not a case when you really do with a sample which you should bring to spectrometer in sample chamber somewhere here. You simply connect spectrometer with a reactor, and you can measure, for example, a process of beer fermentation. And then it must be not only in the labs, and you should not be a professor or a PhD specialist, in this kind of application. Final wish is to develop sensors, and these sensors must be as simple that this guy can also use it, at sitting in Japan, and controlling the sugar, let's say, drying somewhere in Cuba. Because you can transmit data to the cloud, and kind of very simple sensor what I would like to show here. It's a unification at one, distal sensor head. It's a kind of cubic zirconia cone measuring absorption and fluorescence from the same spot. So infrared spectra and fluorescence. One method will help you to distinguish, in this case, it was liver, breast, and fat from chicken, like a model. One method will distinguish only 2 organs from 3. Another method will distinguish another organs. But only when you fuse the data from 2 methods, then you can really differentiate all 3 organs. But the real breakthrough was that we selected not this method, because this equipment costs about 70,000. We simply found a chemometric model and used 1 wavelength in mid-infrared and 1 wavelength in fluorescence. And you see how good it was differentiation. So you have just 2 lamps, and piece of fiber, with this kind of combi spectroscopy. And in result, you can simply, of course, reduce price of the system for 10, 20 times. You can deliver, let's say, signal through so-called TPT cloud. So data from the sensor flying to the cloud. It's real-time treatment of data, and it comes back to end user. So that's why each sensor can have IP address. So that's why you really can do it other side of the planet. You can do it 3-dimensionally and so on. So it can be ecological applications like pollution of the agriculture. It can be controlling these huge fermenters, how to produce biofuel, methane, because you must control it in different areas. And that's why in this field, I see that we are approaching to very new world. We shall develop together customized sensor, which are specific for customer needs. It can be moisture control in cement plant, or let's say for bakery, you should know how much moisture is in flour or in starch. So that's why simple stuff, this boy costs less than 2,000. If it will be volume production, then it will be, let's say, much less. It can be, let's say, maybe 500,000. Then every bakery, every restaurant can control quality of food, or let's say how much alcohol you have in your whiskey, so you really can measure it. So this is my message. Sorry, maybe I'm a bit above my time limit, but I hope you were not, how to say, sleepy under this tsunami of information.
No, Slava, I guess nobody can sleep with your slides. Usually it's a lot of information. Thanks a lot, Slava. So for all of you that couldn't see all the application that Slava showed, there is a recording on YouTube. So don't worry. And the slides are available, right, Slava? And especially Slava is available to answer your question. So maybe you can stop sharing the screen and we make a bit of a summary. Of course, what you said at the end is something that is probably very useful also for your potential customer. So these are examples. There are many examples that you are have shown, but the magic word is customization, right? So all these things you showed are combination of probes that you know from probably some application that are useful, but there are also unexplored combination of probes, right? Can you say a bit more about what is the flexibility there? Where are the restrictions and flexibility, please?
I should say it's a very good question, because to be honest, after 23 years in business, which is named B2B, a component manufacturer, to be honest, I am tired from this role, you know, and we decided to go to the system integration with partners, of course. That's why, for example, it was presentations about short pulse lasers. Great. Then for medical diagnostics, so-called FLIM technology, when you send the short pulse and see how fluorescence is changed in time, it's already kind of, let's say, fusion of important components, short pulse lamp, laser, and fiber optic delivery. And then you need spectrometer, which will simply control fluorescence. So that's why my wish and great interest in EPIC partnership, you know, that we are already among, I don't know how many partners today, 750 more. We should really, how to say, try to find groups in our club which are united, you know, for the system integration, because there are, unfortunately, I already asked this question a week ago during Mir Alliance meeting, how many system integrators we have in our club? Is it 10%, 5%? I can only say that we are starving for system integration, because, as I said, I'm tired to wait for a quarter of century, you know, that system integrator will come and ask for our components, which are unique, the best in the world, blah, blah, blah. How to find the way to end user? End user doesn't want components. End user wants a complete running car, you know, not only perfect engine, you know, and nice wheels, you know. So that's why, you know, here, I think all of us, especially all presentations I hear, it's still components, guys. That's why, you know, I think where EPIC in general must move, you know, how to increase wish, like company Vigo, excellent example. Why they are progressing so well? Why their business is 10 times bigger right now? They started to make integrated systems themselves. They are not waiting for some kind of nice stranger or business angel who will come to them to help. You know, so this is my message.
But I mean, Slava, we take this as a, you know, it's our task and we know about it. And it's also good that you tell us that this is definitely also the direction we should take for your technology, not only yours. So as you say, it's for system integrator and end user, we are working on it to bring it more and more often close to you and to help you also in the integration then of your parts. That's also part of our job. And
I want only very short request, you know, to Tracy. Tracy, I think, yes, we have already, it's a great advantage of EPIC to have, let's say, marketing information. But to be honest, when I'm preparing my presentations, you know, quite often I see that my data about market are already old. It's good to see, you know, how good it was prediction, because, you know, 5 years passed, you know, is it predicted correctly or it was big mistakes? We need new prediction. And we really, because all of us, we need end users, all of us, even system integrators. But then, you know, marketing is exactly something where, I don't know, I see Carlos on the screen, you know, I think it will be great if we shall have maybe a couple of special webinars or OTM meetings devoted to market analysis. Because it's changed within these 2 years of Corona. it's already dramatically changed. Now we have this terrible news from Russia, you know, from Ukraine because of invasion of Russia, you know. World is changed 4 days ago. And again, it will be changes. That's why, you know, where we are, how we can help people, you know, with our to end users with integrated solutions. I think we should.
Thanks a lot, Slava. I guess Tracy is really into this, yeah, for sure. Yeah, Tracy, please.
Well, first of all, Slava is absolutely right, as he always is. And the market analysis is definitely an art. And I think that what you see out there from much of the market reports are reports that are not grounded in technology. So they start with a certain base of numbers. If they don't get too much pushback, then they continue to grow those numbers over time and take into consideration perhaps some economic factors. But these reports are not good unless you understand the technology. And so there are a couple of very good houses in Europe, both Tomatis and Yole, and then there are a lot of others. And what we're trying to do at EPIC is we're trying to pick those areas that are of great interest for the coming year. And we're creating our own curated reports. We'll never be the best at our forecast because we don't have all of those contacts. And yet we have the knowledge of the technology. So we're trying to assimilate different types of information into the reports that we are creating. And then one thing for you, so there will be a special report coming out in May that I'll tell you about offline that I think you'll be most interested in. And it includes a topic that you mentioned in your report, but I can't mention it just yet.
Let's keep then this for a surprise. Slava will be anyway. Stay tuned. I believe that. So now, sorry to wrap up a bit this topic because now it's time to give the deserved floor to Thierry from SILIOS. So we need still to talk about a multispectral camera that is broad enough to the market, and we want to hear more about this. So Thierry, please, the floor is yours.
Thanks, Francesca. Everyone's hearing me?
Yes.
Okay, perfect. Clear. So I'm gonna share my screen. And thanks to EPIC and to Francesca for giving us the opportunity to present the new toucan, our new baby, our last baby. So I hope everyone is seeing it.
We do. If you go to presentation mode, then we are in business.
Should be okay.
Yes, there you go.
That's fine. So, okay. So I'm going to introduce shortly SILIOS and go deeper in the techno and introduce our new baby, the toucan camera. Yeah. So who we are, in fact, SILIOS is an SME of about 10 people, born in 2001 and located close to Aix-en-Provence. So a bad area that I would not recommend to everyone. And in fact, the birth of SILIOS is based on the use of the semiconductor technology and processes to apply them to the optical substrate and to functionalize them. That means that our core business is micro optics. And macro optics to do what? To do two lines of product. First of all, the one we started with is the diffractive optical element. So for the high power and intense lasers. So we're on many, let's say, multi-terawatt and multi-petawatt laser chains worldwide. So for astronomy, a faceplate for astronomy and space. And a second line of product that we started a bit later on in 2009 to develop, which is the multispectral imaging, and to develop technologies that we have called color shades. So the color shades technology, what's it? In fact, what it is? In fact, it's the realization and the integration of different filter monolithically, sorry for my bad spelling, monolithically on the same substrate, on the same chip. And our filter has got this type of transmission curves. So they are deliberately low Q factor, because it's interference filter, so that allows them to be applied and to be used with wide aperture angles. And so our, let's say, full width height mean is about 20 to 40 nanometer, roughly on our typical filters, and the maximum spectral range addressable is 300 nano. And with the Toucan, we have broken these figures. It's a kind of our let's say sound barrier that we have broken. So let's say attached to this technologies, this filtering technology, we have developed the hybridization. So that means the transfer of the filter on alignment onto a pixelized detector. It could be a CMOS, could be let's say a bundle of diodes, whatever, any pixelized sensors. And we have also developed the technology of align it, and we work on package detectors. That's very important. We don't work on wafer level. And why this? First of all, that lets us independent of any sensor manufacturer, because if you work at the wafer level, you need to have the license from the let's say the semicon industry and the let's say the imagers manufacturers. And secondly, when you deposit your filter, we deposit our filter, we deposit it onto the micro laser array, which means that any light that passes through the filter is focused only on the sensitive part of the detector. No light is lost in the electronic of the pixels. And that's also something that if you do a work at the wafer level that you cannot do. So that's globally, and to go quick, is the, let's say the technology and the approach. And this techno, as it's made on with the semiconductor techniques that allow us to do any matricial organization of the filter. So we work with filter of a size of 4.5 micron square, 4.5 by 4.5 micron square per filter. So that means that we address those type of pixels. And here you have an image of the type of, let's say, our expensive piece of glass that we place on the CMOS detector. So you have understood that, let's say, our aim is to provide the specific multispectral sensor for a particular application to, let's say, also specific customers. But also, in order to let them enter the field of the multispectral, we have developed off-the-shelf product. With a low investment, you can develop your own application, your multispectral application. So we supply off-the-shelf and custom, let's say, multispectral sensor, e-board, and multispectral camera. And the Toucan is one of those cameras. So globally, these are the cameras that we have supplied. We have all the three series, let's say the CMS series, about 1.3 megapixel spatial resolution, the CMS4, 4.2 megapixels, okay, with the 300 nanometer band, so 400, 700 for the visible, globally, 500, 800 for the vis-near, and 600, 900 for the near infrared, let's say the one we call near. And then comes the Toucan, which cover all those range. So we have broken this barrier of the 300 nanometer. And so here is the baby. It's based on the 4.2 megapixel sensor. Okay, 4.2. Let's say the spectral range is 430, 890 nanometer with 10 bands, and again, and with 10 bands and 30 to 50 nanometer spatial resolution per band. So, and I can show you the baby again, but here in my hand, you see it. So it's about a cube of 5 by 5 by 6 centimeters. So it's quite
very
small,
nice. Yeah,
quite compact.
Keep it there. You show it there when you stop sharing.
Okay. And so, in fact, this is it. On why we developed this camera, because when we started with the 1.3 megapixel sensor. So customers were complaining about why not more spatial resolution. Okay, so we made the one with 4.2. And then always, okay, people, yes, but I want to see also the blue. I want to see also the near infrared. But nothing was complex, convenient to what they need. So finally, we took the ball by the horns, and then we let's say, find some tricks to develop this unique camera. Currently, is the only one on the market in let's say, but I have to let's say to precise that it's mosaic filter snapshot multispectral camera. This is the only one of that kind covering the 400, 900 nanometer. And in fact, that's it for the camera.
Thanks a lot, Thierry. Thanks a lot. So now let's
I'm
go
gonna
out.
Up. That's it.
Yeah, and then you're a bit bigger. Show it again. So it's really in your hands and it's really
okay.
that small. Yeah. Yes.
Okay.
Yeah.
Up.
Very compact. Yeah, I remember them from exhibitions.
Voilà. With yes. So you, in fact, the USB power supplied and also the data, but it can also be triggered for an external trigger.
Perfect.
On
Perfect.
4.2 megapixels, 10 wavelengths from 430 to 890.
Yeah, that's very, very nice.
Thank you.
Thank you. So now basically, just to wrap up a bit, it's clearly again, because now you covered all the products you produced so far now are covered in one solution. So as you said already at the end, you were following a bit the custom requirements, right? So people wanted the blue, the infrared, they wanted to be more resolved. So that's basically the results of talking with your customers. Then I have to say, Slava was right? So you're also integrating many things in one product. So you also learn into starting from micro lenses and micro optics to go to the final product. So Slava, you're right as usual. Also SILIOS is developing that direction. But now can I, sure, Slava, please.
First of all, I'm never always right, I'm doing
sometimes
mistakes, I'm learn from mistakes. But one question, Thierry, look, it's a very good product already, but we have actual development project right now to make a multispectral endoscopy imaging. So if your range, which you already expanded, is good for, let's say, visible and near infrared, we have unique fiber optics to make it really in mid-infrared, which is much longer wavelengths, let's say 8 to 10 or what else. Yes, we have partners who simply develop cameras for that range. If it will be your camera and camera from the company Optris, for example, or somebody else from FLIR, do we have a chance if we shall really have a combi endoscope with silica fibers for your camera and infrared fibers for infrared, and then it will be images at two cameras? Do we have a chance to make kind of, let's say, overlap, this hyperspectral, let's say, image? Because tumor is half a degree warmer, but I would like to see invisible range wall of esophagus and position of tumor, which is visible only in mid-infrared. Invisible range or near infrared, it's the same color, but what we can do together in this respect? It's
difficult to say it like that and to do it, think about it quickly.
Easy answer, I know.
Maybe something like the lighting through the optical fibers, and then we could retrieve some kind of fluorescence response or thing like that, thanks to the camera. We have already made some in some other time with a smaller range, some let's say camera for endoscopy, so let's say off the shelves. For endoscopy, so for laparoscopy and also for oximetry. But in fact, it was the light was let's say a bright
but
full range light.
If you have did it already, we shall be interested to see how it was already done, because we are just writing proposals, but plan that we are not going to make only mid-infrared endoscope. We are going really to see in both ranges, because our eyes are not from the snakes, they see only invisible range.
But currently we are not able to go because also there is a new baby. I will do another EPIC members. So we have, let's say, we are going to put on the market mid of this year another camera, but for the shortwave range. So currently, that's the maximum that we can do. It's about 1.7 micron. So we don't go in the
it's
mid.
Understandable.
We made,
but I'm not trying to to push or rush your
no, sure, but it's always interesting to see what could be feasible.
But as you are specialist already to to couple endoscope with your cameras, it's great because it can be even kind of, I don't know, beam splitter in front, or what else. But then we shall use what you have already with endoscope. And we shall simply try to add. We can buy these mid-infrared cameras. It's not a big issue. Question to make system integration and to do it together. So this is the point, and we are open for this kind of, let's say, joint efforts.
Okay.
Very good.
Let's see the exchange later on. So Francesca will pass me your email address.
Absolutely.
So that we can exchange.
That's what I wanted to hear for a nice conclusion of the meeting. Now, just one little thing, if you, Thierry, can maybe undisclose something. So if I see it correctly, your new camera basically is playing a lot with the mosaic filter in front and a bit of also data processing. So a bit of software and no.
Everything is made on hardware.
Ah, okay. So
it's the filter on the filter. We play on the let's say. It's our piece of glass, our expensive piece of glass, but anyway, it's our piece of glass.
I guess then we stop there.
So, but maybe this would solve Slava's challenge. So depending upon your matrix that you build, if you build a specific matrix with specific materials, that might be able to give him the combination.
Yeah,
so that matrix looks very interesting. And I would love to talk to you later about materials that you're using, but I have a hunch.
It's just fused silica up to now, even for the
fused silica. Okay. Well, even more interesting then. The easiest, the most interesting. Thank you
so
thanks
much.
a lot. I mean, thanks really a lot also for this last discussion. Thierry also disclosing a bit information. There is food for thoughts afterwards and for one-to-one discussion. With this, I really would like to thank all the speakers again and all the participants, also those that are watching now on YouTube and will watch it later. It was really nice discussion today. And I hope that we can, keep in touch. If you have any questions that is coming after this meeting, let's just talk to me. I will definitely connect you now, Thierry, with Slava. And for all the others, just shoot me an email and that will be the time that we make the business. Okay? Thanks a lot, everyone. And I wish you a nice evening for those that are in Central European time and watching in the afternoon. Bye-bye, guys.
Thank you.
Bye.